Hi, fellow mathematicians. How are you? Share my screen here and let's get started. I'm so glad you can join me today to learn about length, area, and volume. Let's get started. 8 mouthfuls will equal 1 Jill. And I love Jill's face. I would have that same face if I saw that mouthful like that. And a cup will equal 16 mouthfuls. Bye, Jill. And let's get rid of this cup. And a pint will equal 32 mouthfuls. Now then, we have to fit a mouthful, a jigger, a jack, a Jill, a cup, a pint, a bottle, a quart, and a gallon into our bucket. Will it work? Or will it overflow? Or will we have room for something else to go in our bucket? Let's see. Here's the side view of our big old bucket. Let's pour in a gallon first. A gallon will go to about right here in the bucket. Now let's add a bottle. A bottle will fill up this much of the bucket. We'll add a quart. A quart will take up about this much of the bucket. And we're going to add a pint. And now then, let's add a cupful. And we're going to add a Jill. I just love Jill. And we're going to add Jack. Come on in, Jack. Don't be scared. There you go. Bye, Jack. And we're going to add a jigger. Jigger takes up about this much of the bucket. And now let's add a mouthful. Oh, what is this that I see? There is room for another mouthful. You would think our bucket would overflow with all of this in there, especially with a Jack and a Jill, but it didn't. We have a mouthful left over that we could add to this bucket. Before I move on to question number 2, I want to explain about area and perimeter. Area is of a flat surface or a plane figure. It isn't dimensional because if it was, we would be working with volume instead of area. Imagine how many square units can fit inside of this plane. This figure has an area of 20 square units. Each one of these squares is 1 square unit each. And if you counted these, you would count to 20. Different shapes use different formulas to figure their area. Here's the square formula for area, and here's a trapezoid, and here's the formula for a trapezoid, and you can read all of these on your own. Now let's talk about perimeter. Perimeter, let's put up an interesting shape. How about that? That looks interesting, right? Perimeter means that we take the sum of all the sides of the figure and total them together to equal the perimeter. In other words, if we walked around all the way around the outside of this figure, we would figure out the perimeter once we sum them all together. So let's sum 10 plus 2 plus 8 plus 10 plus 10 plus 28. I'm getting tired of walking. How about you? Woo. Plus 2 plus 9 plus 5 plus 15, and our perimeter equals, say, 90 centimeters. We could use any kind of measurement. We could be centimeters, inches, meters. Okay, now we're going to move to number 2 question. And we are asked to find the area and the perimeter of this triangle right here. We're going to use the formula of area equals 1/2 times base times height. The base of this triangle is 82.3 meters, and the altitude is 41.0 meters. An altitude will go from the vertex of a triangle straight down to the base of the triangle. And the altitude is our height in the area formula. So area equals 1/2 times 82.3 times 41.0. And our area equals 1,687.15 meters squared. To find the perimeter, we need to sum all the sides of the triangle, the legs of the triangle, together. So perimeter equals 48.0 plus 82.3 plus 69.0, which equals 199.3 meters for the perimeter. Does the triangle base have to be on the bottom? No, because we can use the 88.8 inches for the base of this triangle to find the area. Use the formula for the area of the triangle, which is 1/2 times base times height. Plug in our numbers for the formula, and we have area equals 1/2 times 88.8 times 37.0. Area equals 1,642.8 inches squared. To figure the perimeter, we're going to sum all the legs of the triangle together. And the perimeter equals 37.0 plus 88.8 plus 96.2. And our perimeter total equals 222 inches. This triangle's base will be 6.2 centimeters right here, and the altitude will be 2.6 centimeters. Who can remember the area of the formula for a triangle? Area equals 1/2 base times height. Plug in our numbers, and area equals 1/2 times 6.2 centimeters times 2.6 centimeters. This gives us an area of 8.06 centimeters squared. To figure the perimeter, sum all the sides together. Perimeter equals 3.1 plus 8.5 plus 6.2. And our perimeter has a sum total of 17.8 centimeters. Here we have a large circle with a square inside of it and a smaller circle inside the square. To find the area of a circle, we need to use the formula of pi times r squared. Because our square has a side length of 10 units, you can see right here, 10 units. The radius of the smaller circle will be half the length of the squared side. Half the length of this side right here, 10 units. The smaller circle has a radius of 5. Let me show you. The middle of the side of the square is about right here. Let the top half of the side of the square fall down into the smaller circle, and you have the radius, making it 5 units. By using the area of a circle formula, we find that the area of the circle is 25 pi units squared. Now to find the radius of the larger square. The larger circle will have a radius the same length as half the diagonal of the square, only half. And we need to use the Pythagorean theorem to figure out the radius. We only need to use this portion of the diagonal because remember I said that it was only half of the diagonal, this portion right here. By the way, the Pythagorean theorem is awesome. The Pythagorean theorem looks like this. A squared plus b squared equals c squared. The c squared will always be the hypotenuse of a right triangle. take 5 units, which is one leg of our right triangle over here, plus 5 units, which is the other leg of our triangle, and we get 50 units. The radius is 50 units. We need to find the area in between the small circle and the large circle, this area right here. To do this, we're going to take the area of the smaller circle, which is 25 pi units squared, and we're going to subtract the area of the larger circle, which is 50 pi units squared, to equal 25 pi units squared. I don't know if you noticed or not, but the smaller circle has an area of 25 pi units squared, and the area of the region between the two circles has an area of 20 pi units squared. I just thought that was neat and interesting. Gotta love math. We were asked to find the volume of the cone, the cylinder, and the sphere. First, we are asked to show how we will find the volume of the cone, the cylinder, and the sphere. Start by using the formulas for the cone, which is pi, which is pi radius squared times height, and we get 1/3 pi radius squared times 2r. Because remember that the height of our cone is 2r. Condense this down and we get 2/3 pi radius cubed. To find the volume of the sphere, use the volume of 4/3 pi radius cubed. To find the volume of the cylinder, use the formula of pi radius squared times height. And our height of the cylinder is 2r. This condenses down to 2 pi radius cubed, and that condenses down to 6/3 pi radius cubed, which condenses down to 2 pi radius cubed. This gives us a ratio of 1 to 2 to 3. The cone has a 1 ratio because imagine if I took this cone inside this cylinder and sphere figure and filled it up with water. If I did that and I filled up the cone only, 1 cone full of water will fill up this cone, correct? This is why it has a ratio of 1. I dyed our water purple this time. Fill up our cone again. 1 cone full fills up the sphere halfway. So we need another cone full to fill the sphere up the rest of the way. This gives it the ratio of 2. How many conefuls of water will it take to fill up the cylinder? I dyed the water green this time. It takes 3 conefuls of water to fill up the cylinder to make it have a ratio of 3. This figure is a right trapezoidal prism. Imagine taking this right trapezoidal prism apart for just a minute so we can figure out the surface area. To figure the surface area of a right trapezoidal prism, use 2b plus ph, because our prism has 2 bases plus the perimeter times the height. And here's our perimeter laid out at the bottom in a long rectangle. Take our right trapezoidal prism and turn it over like I have here for just a moment, because I don't want you to get confused on the height, because 12 centimeters is the height and not 4 centimeters. First, find the area of one of the bases of the prism by using b equals 1/2 times a plus b times h, where a is one of the bases and b is the other base of the prism. Take 1/2 times 26 plus 17 times 12, which equals 258 centimeters squared. Now find the perimeter by adding all the sides together. Perimeter is 26 plus 12 plus 17 plus 15, which equals 70 centimeters. Use the formula that we discussed earlier of SA equals 2b plus pH. The surface area equals 2 times 258, which we found earlier, remember? Plus 70, which is the perimeter, times 4, which is our height over here this time. 4 centimeters will be our height this time. And we get an answer of 760 796 centimeters squared. This is a right triangular prism. To find the surface area of a right triangular prism, we are going to use the same formula that we use for the surface area of the right trapezoidal prism of SA equals 2B plus PH. First, start by using the formula for finding the base of a triangle, which is B equals half times BH. Excuse me. Fill in the formula of half where the B is 8 meters and H is 15 meters, which equals 60 meters squared. Perimeter is all the sides summed together. Take 8 meters plus 17 meters plus 15 meters equals 40 meters. Now plug in the numbers for the surface area formula. The formula will look like this. SA equals 2 times 60 plus 40 times 7, which equals 400 meters squared. Now we need to find the surface area of this capsule. We can break it down into two different shapes. A sphere, the two semicircles on the end put together, a cylinder in the middle. To find the surface area of the capsule, start by finding the lateral area of a cylinder. We can use the formula S equals 2 pi H plus 4 pi R squared. And this will equal our surface area. Our radius is half of the height of 8 foot. We know this right over here. So our radius is going to be 4 foot. Height, or H, is going to be along the top of the capsule, which is the 21 foot. And we plug in our numbers into our formula and we get SA equals 2 pi times 4 foot times 21 foot plus 4 pi times 4 foot squared, which equals, drum roll, surface area equals 728.8494956 foot squared. But we don't want that long O number. No, we're going to round it down. We get 729 foot squared. Now let's find the volume of this capsule. To find the volume of the capsule, we're going to use the formula of volume equals 4/3 pi radius cubed plus pi radius squared times height. Again, R is radius and H is the length of the capsule, or our height. All that is left to do is plug in our values and solve. Change the formula to look like this. B equals 4/3 pi times 4 foot cubed plus pi times 4 foot squared times 21 foot. Now solve, and we get 1,324 foot cubed. Let's find the surface area of this lovely figure. To find the surface area, we need to use the formula SA equals pi R squared plus pi RS plus 2 pi RH. Let me explain why we use this formula. Because when we break this figure down, we get 3 different shapes: a circle, a cylinder, and a cone. We need to sum together parts of this figure to calculate the surface area of this figure. We need a circle and its formula. We need a side of the cylinder and its formula, and the top of the cone and its formula, where R is the radius, S is the slant height, and H is the height of the cylinder. The radius is 2 meters, the slant length is 6 meters, and the height of the cylinder is 10 meters. All we need to do is plug in our numbers and solve. The formula will look like this. SA equals pi times 2 meters squared plus pi times 2 meters times 6 meters plus 2 pi times 2 meters times 10 meters. And our answer is 176 meters squared. Now let's find the volume. To find the volume, we need to use the formula of volume equals pi R squared H1 plus 1/3 pi B H2. R is our radius, which is 2 meters. H1 is the height of the cylinder, which is 10 meters. B is the area of the base of the cone. H2 is the height of the cone, which is, oh no, I don't have the height of the cone. Whatever will I do? I know what we can do. We can use that awesome Pythagorean theorem that we talked about earlier. Use the Pythagorean theorem and we get square root of 6 squared minus 2 squared equals 5.66 meters. Now we have the height of the cone. Now we're going to fill in the formula, calculate, and we'll figure out the volume. Volume equals pi times 2 meters squared times 10 meters plus 1/3 times pi times 2 meters squared times 5.66 meters. And our volume equals 149 meters cubed. This concludes my lesson on length, area, and volume. You can learn anything. Jessica out. Thanks for listening.